next speaker has been a constant partner since the beginning of ultrapolymers. As one of the largest polyolefin producers, and for PE the largest, the impact of LyondellBasell in the era of sustainability should not be underestimated. And therefore, join me in welcoming Alessandro Guidicini and Mathieu Lecomte.
Okay, thank you, Marcus, for the introduction. So we are going to present you our sustainability approach. You will see there are some similarity which was presented before, which is good because that means as an industry, as a plastic supplier, we are going into the same direction. I'm a commercial manager for the healthcare market segment, and so I will present together with Alessandro, who is the application development technical support for the same market segment. This is the agenda of the presentation. There are two parts: an introduction about our company, a briefly presentation of the company. We will also present how do we treat medical plastic, medical polyolefin grades, which are sold under the brand Purell, and we will move to the sustainable needs of the healthcare industry and how do we respond to these needs. But first, let's go quickly to our presentation of the company. So we are a leader in the chemical industry, one of the largest producer of polyolefins, also a leader in the technology of polyolefin production. The company is very focused on sustainability. We are a lot focusing on technology that will enable a circular economy, a low carbon economy. We are present in various types of applications, which is transportation, food packaging, also the pipe that serve to supply the clean water in the cities, and of course we are present in the healthcare application. Our products for healthcare application are sold under the Purell brand. This is not only a brand, there is a service protocol behind with 3 pillars, which are about the portfolio. We have a very comprehensive portfolio in polypropylene and polyethylene. A dedicated team in terms of technical and sales for this segment. We provide leachable and extractable, which are important data, especially for the pharmaceutical packaging when you want to understand the interaction between the content and the packaging. In terms of quality, we have a dedicated quality assurance program on the manufacturing side, but also on the logistics side. That's one of the reasons we have been able to certify our plant in Wesseling and in Frankfurt ISO 15378, which is the ISO norm about the design manufacturing of primary packaging for pharmaceutical products. And the last pillar is about the change management and the regulation. So we have change management with a rule of 2-year notification in case of a change in a product. And we comply with the European and the American pharmacopea. Last point also that I want to mention, there is a definition of the medical grade plastic by the VDI, which is the Association of the German Engineers, and we comply also with this definition from VDI. So let's move to the sustainable needs of the healthcare industry. So I'm starting with a poll that was made by CPHI. So CPHI is a trade show, an important trade show in the healthcare. And what you see from the results from this poll is that almost all of the pharmaceutical companies have sustainability targets, but only 25% have already made some progress, some plans to improve sustainability. So this is still a topic which is under reflection. What are the important aspect of this poll is that first we are talking about the green gas emissions. So there was a study, I think, some years ago that showed that about 4.4% of all the green gas emission is coming from the healthcare. So that's a significant number. And we understand that, of course, the pharmaceutical company, they want to work on that to reduce their carbon footprint. And I think 70% is coming from the scope 3, so meaning scope 3, meaning the raw material. That's what we need to play a role, and we can play a role in improving the green gas emission in the healthcare industry. The other important item are life cycle analysis, so you come back to the carbon footprint, but also the waste management, single use versus reuse. And here you will see we have some products which are recycled products that also can support this topic to improve the sustainability for the healthcare industry. So our product, our sustainable products are sold under the name Circulen. We had already some talk about with the previous presentation of the different product, and you will see kind of the same proposal with first the mechanical recycling. So here we are talking, this is sold under Circulen Recover. So here you sort the waste, you wash it, regrind it, and reform the pellets. It does not comply with the food and even less with the healthcare requirement. But when it's not in contact with the pharmaceutical solution, you could think for instance, for the secondary, tertiary packaging, it's a possibility to use mechanical recycling. The other proposition, which in that case comply with the healthcare requirement, are first the Circulen Revive. Here we are talking about chemical recycling. So that means you come back, that was explained in the previous presentation, but you come back to the molecular level of the molecule. You come back to the ethylene, propylene. That's why, of course, you can comply with the healthcare requirement. In that case, so the recycled feedstock is mixed with conventional feedstock in our site and is allocated to the Circulen Revive, so the recycled material, through a mass balance approach, so certified by ASCC. So very similar what we have seen before. Yeah, and the last proposition is about the Circulen Renew. Here we are using bio-feedstock, bio-waste. So we are using mostly cooking oil. So we are not in competition with food because we are using waste for the food industry. Again, this is the same. You propose a mass balance approach. That means we mixed this feedstock with conventional feedstock and is allocated to the Circulen Renew based on a mass balance approach and certified by ASCC+. In that case, you can claim a significant reduction of carbon footprint, first because you don't use fossil, and also you can consider that the plant, because it's bio during their growth, they absorb CO2, so you can go even to CO2 negative for this product. Next to that, we are also some target to achieve the net zero by 2050 and some interim target in terms of green gas emission. 42% for scope 1, scope 2, 30% for scope 3. How are we going to achieve that is we will improve the efficiency, the energy efficiency of our process. We are also buying more and more renewable electricity, and we are working, I think that was mentioned during the Plastic Europe presentation, on use of hydrogen and also carbon capture. So in conclusion, for the Circulen proposal, they are indistinguishable because in the chemistry you cannot really, you come back to, when it's come to renew of renewable feedstock and chemical recycling, you cannot, this is the same molecule, you go back to the ethylene, propylene. They are dropping solution, that means you don't need to go through the approval process, especially on the mass balance, because you will be supplied with exactly the same product, but in addition to that, you buy a certificate. Traceable, because we use the ASCC Plus certification. The availability global, And also, it's scalable. I mean, one example, last week, we had the ceremony of we are building a plant, a Morotech plant, so a chemical recycling plant using our own technology, 50 kiloton per year in vesseling, so to produce our industrial scale chemical recycling product. Now, I will leave the floor to Alessandro, who will show you how also innovation and polypropylene can help to the sustainability goals.
Okay, thank you, Mathieu. I would start thanking Ultrapolymers for this opportunity, which is giving us to promote our development in this field of application, so in sustainability in healthcare, and in this particular case by using polypropylene as an alternative material. The fields we are screening in these days are at least three, or at least those are the trees that are covered by the presentation. So medical bags. It is very generic as a concept, so we are considering all the different kind of medical bags as a potential field. Blisters, and here in blisters is more focused on pill blisters, so blisters for pharmaceutical pills, and then medical devices, and also in that case it is not a broad concept, but we are focusing on a specific part of medical devices. So in film for medical bags, you know, and you may know that well, the material mostly in use is PVC. In this, I would also thank Alexander and the presentation, the very first presentation given today, as it was a very good introduction in showing that PVC is a material widely used in significant amount, but also that there are concerns related to the recyclability of that material, and also on the toxicity, let's say, of this material even when landfilled or when trying to be recycled because of potential toxic release of substances which can be harmful for the environment. And this is the benefit we have in promoting polypropylene as an alternative solution. Well, polypropylene as a benefit in terms of recyclability, in terms of environmental impact versus PVC, and for that we developed many different materials. I'm going to show in the next slide, in trying to cover the different layers which are typically part of the film structure in medical applications. So this is the slide where is shown our portfolio, but I would start from the bottom part of the slide where you see how a film for medical application is very generically made out of. So again, it's a very generic concept, but typically is made out of 3 layers, where the outer layer is the one providing the thermal resistance, because you may know that, well, it is the layer in contact with the sealing bar that has to apply a force and the temperature to have the inner layer being sealed with the inner layer on the opposite side of a bag. And that's why the thermal resistance is the main property needed for the outer layer. Opposite, the inner layer, which is the layer in contact with the pharmaceutical solution, has to have the lower melting temperature, the better sealing properties, and also, last not least, the low migration. So that's why we, in the development of our material, we considered the use of a specific additivation to try to limit as much as possible the migration of additives into the solution with the risk of interacting with the solution. The core layer is the biggest part of the film, And it is the part which has to provide the mechanical properties, so flexibility, toughness, but also the optical, so transparency and so. And to meet those properties, the again generic, let's say, base polymers for to cover those requirements are you can see in the right side of the scheme, where, of course, homopolymers for better thermal resistance in the outer layer. In the core layer, it is used a typical a blend or compound of a soft polypropylene, so random copolymer plus a huge amount of a plastomer. Well, we have seen also typical ratio of 50-50, meaning that there's a very huge amount of plastomer used for those kind of compound. And then the inner layer, where random copolymer is often used. Said this, we can look at the upper side of the slide, where you see our portfolio. So we have tried to, with the existing materials, but also with the incoming development, tried to cover all the requirements according with that film structure. So we have an homopolymer, Purell HP 572M. We have a couple of random copolymers meeting different conversion requirements, because the main difference between the two is the fluidity. You see, one is 2 mel fluorate, the other 8 mel fluorate, so meeting the requirement in blown film or in cast film conversion. And those are the, let's say, traditional grades. Then we have development grades on the other side of the slide, where you see one of the very last introduction in our portfolio is Purell SP170G. Here it is called as a Super Racco, is a very highly modified random copolymer, which had been designed ideally having as a target to possibly replace the blend random plus plastomer in the core layer. And you see this by looking at the tensile modulus. So we tried to develop the softer material we could develop in one of our technologies. And this had been achieved. You have a 500-600 megapascal of modulus, on top having this grade, very good transparency and very good sealing properties. That's why we are also collecting good feedbacks in having it used for the inner layer of the film. And then you see the next generation, a material which here is called as super soft, is a grade having an outstanding softness, 200 megapascal, combined with a good transparency. And this is really what we think will be the replacement of the compound polypropylene plus plastomer still in the core layer. In case a plastomer is needed, well, we have also plastomer. The very last is a grade, is a polybutene amorphous material, so still a polyolefin, which has a peculiarity to be very well compatible with polypropylene, can be very well dispersed, mixed with polypropylene for enhanced transparency and softness of the final compound. All this to say that with our offer, we can allow the producer of that film to go to the market with a monomaterial solution, full polyolefinic solution. The second field of application is blisters. And here is, as I said before, we are focused on peel blisters packaging, which is again dominated as a market by PET and PVC or PVC coated with PVDC. And in this, polypropylene can have an advantage because of, if you look at the top right side of the slide, the peculiarity of polypropylene is in having a very good water vapor, a very low water vapor transmission rate. The lower the better, meaning that the lower the number, the better is the barrier. And you see that polypropylene is having a better properties than PET and PVC, almost comparable to the properties of PVC, PVDC coated, depending on the ratio of PVDC. On top of that, polypropylene is also having a good mechanical properties, transparency, and last not least, a very good environmental impact, let's say, versus all the other materials. And that's why we are promoting our polypropylenes for this application. And here you see that we have already a couple of grades of polymers. The main difference between the two, the very last born is a Purell HP 476J, launched in the last few days, which is a 3.5 ml/8, but is very similar to the grade that we have seen also before for film application, Purell HP 572M. So both are homopolymers, both, well, differ from the fluidity, which is linked to the different conversion technologies where one merfluorate is preferred than the other. Here are marked as typical properties like transparency and water vapor transmission rate. And why are marked in that way? To highlight that we are working on developing an even better solution, which will be an advanced polypropylene, let's say, targeting improvement in those properties. So improvement in water vapor transmission rate and in transparency. So, and once again, all that to have as a target the possibility to do those blisters as monosolution applications, monosolution material. So meaning that with polypropylene, we can, the converters can do both the blister and the lid with the polypropylene-based solution. The last field is medical devices, and here, as I said before, we are focusing on a very specific field, and in particular in targeting the possibility of polypropylene to replace some polycarbonate ABS blends, compounds with a polypropylene solution. And here we developed a grade which is called Purell A678P. It is an heterophasic copolymer with outstanding rigidity versus all the other traditional heterophasic copolymers. And when we developed this grade, we tried to compare, let's say, the properties of polypropylene versus PC-ABS, and we found some for which it would be worth considering polypropylene. Density, for example, is beneficial for polypropylene. Polypropylene has a density typically of 0.9 versus the density of PC-ABS of 1.1, 1.2. So it would allow a reduction in weight of 20-25% by adopting polypropylene instead of PC-ABS. The mechanical properties are lower, but as a balance could be close to the ones of PC-ABS. And we think that in many applications, the properties of PC-ABS could be over-designed for the specific applications. So we think this grade could fit with the requirement. And last not least, as well, topic of today's and tomorrow's discussion, the recyclability, the sustainability, the impact on the global warming environment, for which polypropylene is in a very well position versus almost all the other materials, including PC-ABS. And this is the material. So the properties are listed here. It is an 18 ml/8, you see, very rigid, modulus of 1700 megapascal, very good impact resistance even at low temperature. And as all our Purell materials has been tested according with the pharmacopoeias. It is made with an phthalate-based catalytic system and with the adoption of a non-animal-derived additives, as all our polypropylene materials. And the targeted applications are there. You maybe have seen also from the previous slide the picture auto injectors, insulin pens. Those are the main application we are targeting, and we have already some good feedbacks in using this material, but also others, so oral care, transport trays, and other medical devices. So that's all for the presentation. Conclusions. Well, you have seen Purell. Purell is not just a brand, but is a concept which is in line, let's say, with the pharmaceutical GMP in terms of awareness, change control, documentation. So not just a name written on the bags. You've seen from before that we have a family of materials called Circulen, which are supporting sustainability in terms of reduction of plastic waste from advanced chemical recycling, so for the Circulen Revive brand and family of materials, and also support the possibility to have lower carbon footprint by adopting the use of bio-based feedstock on the Circulen Renew grades. So this to say that, well, LyondellBasell Purell portfolio offers solution for all the healthcare applications, pharmaceutical, medical devices, with the possibility for improved recyclability and sustainability. That's all.
Great.